This is a zero to hero, top to bottom, long drawn out presentation on ZFS, which I called Becoming a ZFS Ninja, because most of the topic titles are just way too boring and it sounded very Java 1-y-ish. And I tried finding a bunch of pictures of ninjas, but honestly I've always been a fan of Eastman and Laird's TMNT, so I just, they're awesome. They do not have colored sashes, they're all red, okay? So, and there are no more Ninja Turtles in the rest of the presentation. So, the agenda: we are going to attack the physical, pools and RAID and maintenance of physical devices. We are then going to harness the virtual, talking about data sets and properties. We're going to become masters of time and space with snapshots, clones, and replication. And then we're going to share some of the joy with NFS, SIS, and iSCSI. And we're going to hone the craft with internals and tuning, some of the fun deep stuff to make your friends jealous. And then we're going to advance the fight with some extra goodies like NDMP and Comstar. This is a session in which I want you to actually learn. A lot of the sessions at Java 1 are the sort of datasheet presentations is what I call them. You're supposed to sit there and nod and act intelligent, and then when you get home, go and ask somebody, I didn't understand what the fuck you meant. At this one, I actually want you to engage with me. And in the event that there's a question that you think is off topic or you don't think you want to ask it right now or it's a big thing, that's my email address, benner@cuddletech.com. Please feel free to email me if by some chance you found someone, killed them, and taken their Wi-Fi access. You can mail me now. Or you can just open something on your laptop and mail it later. So feel free to submit questions to me via email, and then I can, take my time to give you a nice, long, verbose response, or just turn it into a blog entry and share it with everyone else, okay? Now, before I kind of get into this, let me do some polling, because a poll is a great way to kill some time. Who currently has never used ZFS? You know what it is, but you've never actually used it. Okay, one person, two persons, thank you. It's very nice. Who hates poll questions and doesn't answer them? Good. I just like to check there's one. Okay, so that's my margin of error. And who feels like they know ZFS well enough to be up here giving this talk? Anybody? One. Awesome. I might call on you. You might come up here. We might just put you on the spot. Okay, that's good. And so everyone else is sort of in between. You've used ZFS a little, but you'd like to learn more about it, right? So that's what I'm going to assume. Okay, so some of this, because we're going from the bottom up, some of this may seem very basic to you, but what I'm going to do is go into a lot of depth on things that might otherwise just be kind of brushed by. So I want you to avail yourself of all these different things. And hopefully, even if there's very little in this presentation that's new, I hope it maybe gets you to think about things a little more that you might have simply overlooked. So let's start with some basics. ZFS is far more than a file system. It's a very powerful integrated storage subsystem. ZFS is a transactional copy on write file system which is always consistent on disk, which means you don't ever have to FSOC the file system. Now, the thing about this is there's two big words in here. One is transactional and one is copy on write. Copy on write is a data management technique in which instead of rewriting a block in place, when you go to write the block, you simply write a whole new block. So you now have an old and a new, and now you reference the new. When you do that, you get certain fun little things that you can do like snapshotting and whatnot, because you kind of have this trail, history trail. It's also kind of very efficient. ZFS is transactional, so we'll get into a bit more. But I want you to know from the outset that ZFS in a lot of ways has more in common with your OLTP database than it does with your existing file systems. It shares a lot more in common in the perspective of concepts from, say, Oracle than it does from, say, ext3 and ext4 if it ever actually works. ZFS is scalable, 128-bit. This is something they talked about in the keynote yesterday, right? You will never in your life need a 128-bit file system unless you find a new universe. But it's there, so there's no scalability issues ever. ZFS is fully checksummed. So everything you do inside of ZFS is checksum for integrity. This is end-to-end integrity from beginning to end. And one of the most important things about ZFS is that it's a revolutionary and modern design from the ground up. It was started by Jeff Bonwick and Bill Moore. Jeff Bonwick is famous for actually doing most of the VM work in Solaris. And so he didn't really have much of a storage background, actually. So when he came looking at the world of storage, he saw something that looked very, very bizarre, which is that we do all these strange administrative tasks with our disks that make very little sense. And we've done them forever, and no one's ever challenged them. Partitioning and RAIDs. In our traditional storage setup, you have perhaps hundreds of disks, which you then combine into RAID groups, and then you mirror in certain ways, and you create a single file system on that. There's a mapping between a volume and a file system. It's all very tedious, very difficult and complex to manage. He was used to VMs, where you put a DIM in and you use it. And the VM is very smart. It figures all this out for you. You don't think about this as an administrator. You just put more memory in it and reboot the system. There you go. And in the case of some of the larger Sun systems, you don't even reboot the system. You just put the memory in and turn it on. So he looked at storage in that light and thought, why can't we use some of the same kind of concepts? So we get this idea of a volume manager and a file system all in one with a bunch of other fun things in the middle as a single product that's now aware of itself. And there are a lot of advantages between a file system knowing what the underlying volume manager is doing, so on and so forth. So it's a very fresh, new, clean sheet design that has a lot of advantages. This is different than anyone else in the industry at NetApp and ERC or any of those guys who essentially keep bolting on technology onto something very old with a lot of old concepts built into it. And of course, one of the things we'll talk about a little bit more and unpack it is ZFS loves memory and SSD. DRAM is really fast. SSDs are pretty fast. Disks, not so fast. But if you have a storage subsystem that's actually aware of the fact that there is this kind of tiered performance, which, mind you, the cost tiers equally, we can do a lot of interesting sorts of things. And this is where we get terms like the hybrid pool, which we'll get into a little bit more. So, when you think about ZFS, I want you to think about this. Okay? Even though it feels like this. Right? And a lot of times people get so excited about the simplicity of ZFS that they forget that in fact there's a lot of complexity actually going on there. Right? Ferrari's a beautiful vehicle. Essentially you've got a pedal and a wheel. It's very easy to use. There's a lot of complexity going on behind the scenes. This isn't an issue if you're a casual user, but as you start to deploy it into production, you're going to realize that it starts feeling like this. And it gets a little scary. Right? One of the downsides to not having many buttons to push is that when anything goes wrong, you start hitting them really hard because you don't have many buttons to hit. So, what I'm going to do is kind of get people up to speed. We're going to do a quick kind of 60-second primer on ZFS. I want you to kind of see it in its quick and easy, quick demo kind of form. And then we're going to build on that so we have kind of a frame of reference. We know where we're going from. So there's only 2 commands. There's actually 3. And if you want to know about the third, go talk to Max Bruning. But you'll never use it. It's called ZDB. There's ZPool for creating a pool and ZFS for creating data sets and things like this. So getting this started is really as simple as creating a storage pool from one or more devices and then creating any additional file systems and customizing them. So let's go and do a little demo. Okay, so this, for the purpose of the demo, if you're curious, I don't trust internet access at these kind of events, so I'm actually running a VirtualBox instance on my Mac. It's running Solaris Express 1.14. I'm not using OpenSolaris only because of the fact that the root file system in OpenSolaris is ZFS. And for the purposes of the demos we're going to do, I don't want that to distract you. Solaris Express actually has the ability to use a UFS route, which means that there's no pools, there's no nothing, and it's nice and clean for us to look at. Okay, so there's nothing confusing. Is there anyone who's not familiar with the format command? Everyone's hardened Solaris pros. Awesome. So the format command obviously is showing my disk. Now, for VirtualBox, one of the things that's nice, this is a great thing for testing, is that you can just create disks, VDIs, and attach them. Right? So it's a useful way to do some kind of testing that you might not otherwise be able to do unless you want to spend a lot of money on hardware. So you can see here, this C0D0 is my root drive. And then the C2, the controller 2, targets 0, 1, 2, 3, and 4. These are all virtual disks, and that's what we're going to use to play with here initially, okay? So I don't actually need to partition, right? This is an important thing about ZFS. You can partition your disks. Don't recommend it. We'll get into that in a little bit more. But you don't need to. So I'm going to give it some whole disks. I'm going to use the command ZPool, because I'm going to create a pool of storage. I'm going to use the command create. It's fairly obvious. I'm going to give it a name, like Java 1. And then I'm going to tell what disks I want to use. Okay? Okay, so I'm just going to pick 3 disks. Okay? Enter. And it returns. Nice and quick, right? Now, I just ran one command. What did it do for me? If I use the ZPool status command, I can see the pool that I just built. It's called Java 1. It's online. And we see the 3 disks here. This is a dynamic stripe. We're going to talk more about that in a second. Now, if I go run df, I can see that Java 1 is actually already mounted for me. These are 1 gig virtual disks that I'm using. The storage itself is 2.9 gigs. It's mounted and it's ready to go. Now, this alone is amazing. Because if I gave you the same VirtualBox instance and asked you to do that with Veritas Volume Manager, that demo alone, to get to this state, would have taken probably about 30 minutes. Right? If you did it really fast and you weren't actually explaining it on stage, you might be able to do it in like 4. But you'd screw up half the commands, which means you'd have to redo it and it'd actually take 8. Right? An LVM on Linux? Please, just shoot yourself. Fundamental change. In the enterprise world, if you wanted something to be this simple, you went out and you bought an EMC Symmetrix and you used a wizard, which actually meant you'd had to have a Windows machine in your infrastructure to run their client so you could connect to the controller, and you'd create a LUN and then you'd import the LUN and it would be there. Right? Even that's more complicated and cost you a couple $1 million. Fantastic. Right? I can go into Java 1. I can touch files. Because who doesn't love a command called touch? Fantastic. It's there. It's done. Guess what? You all know ZFS. Right? And if we use the ZFS list command, we can see our data sets. If we want to create a new one, we can use the ZFS command. It's a command called create. Again, very creative. Java 1/home. Run df again. Look, it's mounted. It's fantastic. You could do this like sitting in a really nice comfy chair in like Bermuda and tell everyone that you're still using Veritas Volume Manager, which in fact was actually your travel budget, and working really hard. Okay? Does anyone have questions about this so far? Okay. We are now going to spend the next 2 hours going over what we just did in excruciating detail, to the point that you will gouge your eyes out. Because all that was really complicated. And you think it's really simple, but you're wrong. It's really complicated. So, let's start by attacking the physical. We're going to talk about pools and physical devices and the fun stuff that actually causes people the most problems. A ZPool, a ZFS pool, combines the traditional roles of volume manager, what people wrongly often refer to as RAID, and the file system. It's born from the idea that disks should work similar to DIMMs. You just plug it and use it. It dumps the old one-to-one volume file system mentality that we talked about before. You go out and you create a volume, and then you create a file system on top of it, and you go create another volume. And of course, what happens when you need more capacity? Well, everything's already strung out, and it's complicated, and you have post-it notes all over your cubicle wall or your monitor trying to remember where everything is, and something breaks, and then you just want to kill yourself, right? And we've all, how many people are long-time storage administrators, right? You've all been at that place where you typed one command and your heart went down here, and you started figuring out where your resume was, right? It sucks. Hate it. Been there. So, and it's all controlled with a single command. Very simple. Anyone who's had to deal with LVM appreciates one command, right? Because you can really remember PV, display, VG. It's too much. So, ZPool components. A pool is created from one or more VDEVs, which is a virtual device, which is a collection of one or more physical devices. There's one little caveat to that, but we'll get to it. And the VDEV types include a disk, which would be like a real physical disk with a disk ID, block device. A file, this is the caveat, is you actually can use a file. Now, it's not something you're typically going to do in production, but it's fantastic for testing, because you don't actually have to use real disks to create pools from. So if you want to see what a ZPool with like 120 disks would do, you can actually just create them as files and mock up the whole thing. And of course, like I said, with this demo, I'm actually using VirtualBox, so you could actually also do that in something like VirtualBox or VMware by just creating like virtual devices. Yeah, we can create mirrors, which is 2 or more disks mirrored together. It can be 3 disks, 4 disks. We have RAID Z1 and 2. If you ever see someone simply say RAID Z, they're referring to RAID Z1. There are 2 different types, RAID Z1 and RAID Z2. These are essentially RAID 5 and RAID 6. RAID 5 being single distributed parity, RAID 6 being double distributed parity. There are some caveats to it. It is actually greatly enhanced, because traditional RAID 5 and RAID 6 have this real problem where you need to update a stripe at a whole time, right? You update some data, you now need to read all the data back so that you can calculate the parity, so you can write out the parity disk. So the big gotcha is, what happens is if you lose power between the time that you wrote the block and you rewrote parity? You now have this corruption. It gets really nasty. And this is what Jeff Bonwick and others refer to as the write hole, the RAID 5 write hole. And mind you, we're talking microseconds, potentially, maybe milliseconds. But it is there, it does exist. ZFS does away with that problem because it's transactional, it writes everything at one time. So you don't have that issue. But if anyone says, well, it's RAID 5, RAID 6, but better, that's what they mean. Solve the write hole problem. So RAID Z1 and RAID Z2. Then we have these special types of VDEVs, a spare, hot spare. Now, a log device and a cache device. This is where we get into these concepts of the hybrid pool, and where you use SSDs, and we say that ZFS understands SSD. Is you can actually add a VDEV as a log device, typically an SSD, which is actually going to help increase your log write capacity. This is ZIL offload or SLOGs, separate intent logs, right? Typically you'd use an SSD there, and we'll get into this a little bit more, but the idea is when you go to do writes and you need to log those writes, it'd be really nice to have something really fast to take those and log them so you could return to your client as quick as possible. So there's a log device. And then on a similar side, there's a cache device, which is a read cache device, which is also known as L2 ARC. That is that you have this big read cache in memory. And what if you want to make that read cache bigger than you actually have capacity for in memory? Well, what if we used an SSD to extend that? We have a level 2 read cache. We said those two we're going to get into a little bit more, but I want to be complete. Okay? So disks and files, mirror, RAID Z1, RAID Z2, spare, log and cache. Okay? Does that make sense? So, RAID concepts. Dynamic stripe. This is the fundamental way. If you don't specify mirrors or RAID Z, you're going to be doing a dynamic stripe. It's an intelligent RAID 0 essentially. Then we have mirrors, which is an N-way RAID 1. RAID Z1, improved form of RAID 5. RAID Z2, improved form of dual parity RAID 5. And you can combine these together using dynamic stripe. So if you wanted to create two RAID Zs, it would be dynamically striped together. The reason we call it a dynamic stripe is because of the fact that not everything in the stripe has to be the same. They can actually differ in size and type. So you can actually, and we're going to see this in a second, you can actually have a RAID 5 and a RAID 5 and a mirror, all dynamically striped across. Would that make a lot of sense? No. You'd be mocked and ridiculed by your friends, quite rightly so. But you could do it. Now, on this one thing of RAID 6, is everyone clear on RAID 6? Is there anyone who's confused about dual parity RAID? Very good. So, we're going to let's look at a simple example. This is like the demo I did before. In this case, I'm using the ZPool command to create a pool. The pool is called MyPool. And I'm using 3 devices. And I now get a dynamic stripe of 3 disks. Right? Nod. Yeah.
I've got a question. What's dynamic about a dynamic stripe?
Dynamic about a dynamic stripe?
Yeah. I mean, is there some algorithm that says that we shall distribute it here, here, and here, or is it?
No, it's sequentially around, but it's dynamic in the sense that it can grow at any point in time. It is not a static, fixed capability. So one of the problems you'd have in some RAID systems is you'd create a stripe and it was yay big. And you could only increase the size of the stripe if you did it in, say, equal intervals, or if it was an exactly identical device to what was currently in it. And the dynamic sense of it is that it can be small. So we could actually have a 100 gig disk, 100 gig disk, 10 gig disk. And then we could go and add to it again another 100 gig disk or a 1 terabyte disk. Right? We have a lot of flexibility. It's very dynamic in how it approaches that. And the dynamic aspect is really in how deep in the bowels of ZFS that it actually writes out to the data. It's adaptively, dynamically adapting to the write pattern as it goes through. Okay, so this is a dynamic stripe, RAID 0. Clear? Okay. Now this one. What is this? Anyone want to tell me what this is? Getting close. Oh, don't say that. RAID 10. RAID 10, I hate that. The plus sign needs friends. Don't go to excluding it. Okay, so here we're creating a ZPool, right? Named MyPool. And now each of these are, here's the thing I want you to catch. Each of these 2 following lines are single VDEVs. So they're actually 2 VDEVs. Each of the VDEVs are a mirror. Each of those mirrors contain 2 devices. So we're actually dynamically striping 2 sets of mirrors, right? So this is RAID 1 plus 0. Okay? Does that seem a little awkward at first? Like I said, I'm going to go into this in like so much detail that you're going to be like, wow, I didn't know it was that hard. You're going to think that ZFS is really complicated at the end of this. You walked in thinking it was simple. It's complicated. Okay. Let's make it more fun. Oh, look at that. Told you, it's much harder than you think. Don't get trivial. Okay, so here, ZPool, create, MyPool, right? And how many VDEVs do we have here? 1, 2, 3, 4, 5, 6. Okay? The line breaks are kind of a hint. But that's important, okay? Does everyone get this concept that we have actually 6 VDEVs here? Okay? And each of those VDEVs has a different classification. We've got 2 mirrors like we had before. Then we've got a RAID Z VDEV, which actually has 3 devices, because RAID 5 on 2 devices is stupid. Then we have, thank you, I don't want my. Then we have a log device. We have a cache device. Then we actually have a spare here. We're specifying 2 devices as spare. So VDEV device spare with 2 devices. Okay? So who wants to tell me what that configuration is? Seriously, I'll give you like $10 if you can figure it out. Because I couldn't. So it's like the hybrid pool of terror 1/1/5+0 or something. I don't know. But maybe there was like somebody who was really hardcore who'd be like, oh, I know exactly what that is. But you can do this. This is totally valid. You can totally do this. It's stupid. It's retarded. It might look cool on a t-shirt. But you can do it. Now, we used to see a lot of these sorts of things in like the Veritas Volume Manager world. That was a place where you could do all kinds of really stupid and crazy things, right? The point of this is that you're probably not going to do it, but you can. And believe it or not, if you're a hardened storage administrator, at some point, this might actually seem like a good solution. It might. So I want you to know you can do it, okay? But remember, like I said, there are 6 VDEVs. When you think VDEV, think of the construct. There is a mere VDEV. There is a mere VDEV. There is a RAID Z VDEV. There's a log VDEV. There's a cache VDEV, right? A lot of people, when they think VDEV, their brain goes, oh, I see a hard drive. Device, hard drive, that must be the VDEV. No, okay? Because then you start getting confused when you try to do really advanced configurations like this, okay? So, now, to that extent, you probably now want to actually try doing that. Go ahead. I'm supposed to ask you to use the mic, but you don't have to. I don't care. But they do, and I want to be nice to them. Because they work hard. They work for a living, unlike us.
So when you go back to your very first example, when you just made ZPool 3 disks, does it just default to RAID Z?
No. Dynamic stripe. So in this, if you don't see it specified, the default is dynamic stripe. So if you don't see anything, it's dynamic stripe. We're going to flesh this out a little bit more in a sec. Okay, so now I want to throw this in. I mentioned file VDEVs. File VDEVs are nice because you can create these non-existing devices to play with, which if you wanted to do stupid configurations, you can do, which is fun to blog and show your friends. But it's also really, really handy when you want to, say, configure some new storage array that you bought. You told your boss you really had to spend $250,000 on this new hardware array. And you're terrified that the first time you configure it, it may not be the optimal configuration. You're not quite sure how it's going to work or fail or something. You could actually create file VDEVs and mock it up in the same configuration and then play with it, break it, see how it goes, right? That way when the real device shows up, you're like Scotty and you're there, right? Simon Pegg as Scotty, awesome. Okay, so files can be used in place of real disks, but they must be at least 128 megabytes in size, pre-allocated. Huh? Is it 64 now? 64. At once upon a time, it was 256, and I actually wrote the slide and said 256. Then I went, I should check that. And I checked it, and 128 worked. It depends on your build. Start at 64, see if it works, then go up from there. Actually, it's like 64 plus a byte or something. Anyway, so you can create these files. Best practice is to store them in a common location, and this is not intended for production use. There may be instances where it seems like a wise idea, and you may actually need to do it, right? Maybe there's a case where you have a symmetrix that's completely useless, except it's got a big LUN, and you can create a file and use it. God bless you if you can find ways to do that, but be careful. So, now we're going to go and play with pools. So, here we have this dynamic pool that I created. And let's say, as a first example, let's take that pool, and I've got more devices here. So let's go ahead and increase the size of this pool. ZPool. Actually, no, I'm not going to get into that quite yet. I'm just going to destroy it for now. Okay. So if I wanted to create a RAID Z, how would I do that? ZPool, create, RAID Z, C2, T, 0, D. Oh yeah, I'm all excited. Okay, so there's one VDEV. So we'll create another RAID Z. 3. No, I can't. Right out of devices. Create them. Okay. Here's one of the other things you may run into. If you create a pool on something that's already been created, you'll actually have to use the force flag. Okay. Look at that. Man, that's ugly. Ugly. This is not something you could run into a data center very often. You'd be surprised how many people do this on like their workstations at home. Because you know your workstation, you're constantly upgrading it. And so you probably still have like a 60 gig drive and a 120 gig drive and a 500 gig drive and a 1 terabyte drive. And pretty soon you have a 2 terabyte drive. And you don't want to toss them. You can do that. So here we are dynamically striping a RAID Z1 VDEV and a mirror ZDEV. And you can see the devices. Okay? Okay? Is that making sense? Somebody say you're getting boring because we now understand. No? Thank you. All right. And if you get really good and bored at this, come up here. I'll give you a job and I'll send you off to go and do this for real this afternoon. I won't pay you, but you'll feel good for helping. Okay? And so we can just add more and more and more. Now, let's go ahead and play around with these file VDEVs. I normally create, now mind you, this is not a real directory, but I normally create a /ZDEV directory where I create these files. And so let's go ahead and create, I think I created this 128. But we can pre-allocate a file. So we just mk file 128m bdisk 002. I like to name them sequentially like this. You can name them anything you want. I just call them vdisk and put them in a ZDEV directory so that I remember, because I have a very bad memory, which is why I write a lot of blog entries. They're not for you. They're for me. I can't remember anything. Maybe we'll create one more. We'll destroy Scotty. So now we have these 3 files. I can now create a pool. Create a pool, and we'll just do RAID Z. I'm going to have to force this. And you do have to use full paths. Okay. And now the output's going to look all kind of ugly because you can have real paths in here, okay? But there you go. Okay, so we have a RAID Z1 consisting of 4 files. Okay? So it's a handy tool. It's a good thing to know about. You can do all kinds of fun things in testing. This is particularly good, I will tell you, if you haven't gone and actually replaced live devices or tested failure scenarios, you may not have a nice big server where you can hot swap, drives out. So this is a really great way to, like, say and go write garbage into one of the files just by, like, catting dev random into one of these files and then seeing what ZFS does when you write data to it. Things like this. Okay? It's always nice to trash things without actually trashing hardware. Okay. So. Okay, we're going to talk about some more topics in here, and then we'll go back and do another demo. So, scrubs. Scrub is full data verification. As you're reading data and doing I/O on your ZPool, it's, like I said, it's all checksum, so it's coming up through the ZIO pipeline into ZFS, and it's being checksummed to make sure it's the right data. The data on the disk is, in fact, the data that you're asking for. It's very intelligent that way. But obviously, you're probably not reading every block of data on your ZPool frequently, right? There's probably a lot of data that's just sitting there, and who knows what's going on. You may have issues with bit rot, or if you have a RAID controller underneath, you may have some kinds of problems there. So a scrub is simply a way to basically read in every block off disk and check it to make sure it's happy, right? I do recommend that you, my personal motto is scrub early, scrub often. Once a week is pretty good, maybe 2 weeks. It will dramatically slow down I/O depending on what kind of physical devices you have, because it's reading in everything on disk, right? It's going to read every byte there is. If you have a couple terabytes, that could take a long time, right? Or especially if you're doing something like iSCSI, it could be really painful. But because it verifies all the on-disk contents and fixes problems if it finds them, if you're not scrubbing, there may be problems in the file system on the underlying disk structure that you're not aware of. And there's nothing suckier than finding out at 3 a.m. that there's some type of corruption or something. So scrub early, scrub often, know what's going on. Okay? Best way to do this is via cron. Just put it in there whenever you want it to run, and do it in off hours. And of course, make sure that you watch out for your backup schedulers or something like that. If you're backing up data off a ZPool that you're scrubbing, you could make both of them very, very slow. Pools are portable. Once you've created a pool, you can import or export it. Now, when you create it, it's imported transparently. When you shut down a system, it will actually export the configuration, export the pool, and shut down. When you fire it up with like OpenSlash, you'll actually see reading ZFS config. It's actually a file in etc/ZFS. It's called a ZPool cache file. It'll read that file to get an idea of where all the disks are, so it doesn't actually have to probe all the disks, and it will bring the pool up into a full state. So you actually can, on a running system, export the pool, right? All of a sudden you run ZPool status, you see nothing. You could take those disks, physically remove them, go to another box, plug them in, and type ZPool import. With no arguments, it will just probe all the disks to see if it finds a pool. It can find the pool and import it and use it. Okay? This is something that the cluster guys can leverage in certain instances to do failovers and things like that of pools. That's something that Nick will be talking about quite a bit. Well, I think in passing, but you could talk about it quite a bit. Yes, sir? When you run a ZPool import, it will read the headers off all the disks and see if there's a pool, and if it is a pool, it'll import them.
So there's no central data that needs to be moved on?
No, there is not. I said, let me, in case I confused anyone, I said there's a ZPool cache file when you boot the system. That is purely to speed up the process. So if it finds a ZPool cache file, it already knows where the disks are, in what order they go in, and how it needs to import it. So it doesn't actually have to go out and probe all the disks every time it boots. That would slow down boot a lot. It's just a way to speed it up. If that file doesn't exist, all it means is the pool won't automatically import. So you actually need to explicitly run an import. And the cool thing is because of the header information on each of the disks, they don't need to be in the same order, with the same names. Right. So, right. Well, one of the fun demos that people have done is they'll plug in a bunch of USB sticks, create a pool, then pull all the USB sticks out, jumble them up in a hat, and then plug them all back in, and it just imports fine. Right? No, it's pretty quick, but it depends on your configuration. You may have a machine, like say a thumper with 48 devices. Probing 48 devices takes a little time. It's like 2 minutes, minute maybe, sometimes faster. But it could potentially take a while. So the ZPool cache helps. And here's a little tip. I won't get into this, but since I'm mentioning it, if you have a Solaris system that for some reason is having a problem with the ZPool and you cannot get the system to come up because the ZPool's junked, boot it into failsafe, go into etc ZFS and destroy that ZPool cache file. And when you boot the system, it will not import the pool. But that's not a basic concept. Okay, so ZPool maintenance, the fun part. ZPools are really nice and easy and awesome until you actually have to replace like a disk and a thumper where it's like, oh great, there's 48 devices and I have to pull one of them out and it better be the right one. It's fun. I've done it a lot. You can manually spare pool disks with this ZPool replace subcommand. Very simple and intuitive. Specify the old device and the new device. C0, T1, D0 with some new device. You can actually do in-place replaces as well. Devices can be online and offline via ZPool online and offline. There are a number of ways in which online and offline can be useful. If you have, say, a mirror, and you have say you're mirroring two different disk arrays, and you need to upgrade the firmware on one of the arrays, you're not going to take the array away, but you may need it to just be, alone for a little while you do the upgrade. You can just offline the device, do what you need to, and then online device. Online, when you offline a device, all you're saying is, if something happens to that device, you don't care. Just ignore that thing. If it disappears, if it goes off, if it resyncs its loop or something like that, I don't really care. Right? So it's a great tool for helping you do maintenance. It's also a good practice if you want to do a replace on a device and you're afraid of how it may react when you offline it. Rather than just doing a replace, you may want to offline the device first and then replace it. There's a number of ways you could play with that. Now, here's the thing that can confuse some people. A device rebuild in ZFS is known as a resilver. Okay? They use a different term than a rebuild because a rebuild is a term used in classical volume managers where the volume manager didn't actually know what it was managing. It just sees a bunch of blocks. It has no understanding of what these blocks are or what they're doing. Because we have a file system and a volume manager together, we have some idea of what the data is. So resilver is a very intelligent sort of rebuild because it knows what it needs to rebuild and how it needs to be rebuilt. And so if you see that term resilver, it is totally fine for you in your mind to just interpret that as rebuild. Okay? ZPool attach and ZPool detach. These are for actually adding or removing devices from an already redundant group, like a mirror. Right? So if you actually try to detach a device from a dynamic stripe, it will say no, because there's no redundancy. So it's a nice way if you have, like, say, a three-way mirror, because you just have tons of like Hitachi disk arrays or something like that. And you have three of them mirrored, and you decide it's time that you want to reclaim one of them, so you want to go from three-way mirroring to two-way mirroring, you would detach the device. Okay? Likewise, if you wanted to add a mirror to a device, you would attach it. Okay? And that's actually one way that you can take a dynamic stripe of devices and change them to a RAID plus 1 plus 0 by attaching devices to each of the individuals. Okay? And then growing ZPools. Of course, that's one of the important aspects of ZFS is that we want to be able to add disk as we need it, and we want it to be nice and easy. So we simply use the ZPool add subcommand. And here's a number of different examples. The first one, we just add my pool and a mirror VDEV of two devices. In the second example, we're adding two spares as a single VDEV. In the third example, we're adding a log device. And in the last example there, we're actually adding a RAID Z2 of 3 plus blah, blah, blah devices. I ran out of a slide. Okay? So you notice you're adding a VDEV to an existing pool, and the VDEV has physical devices. Okay? That's why I said you need to be very, very, very clear on this whole VDEV idea. Otherwise, that looks really weird. Right? Okay, so is that making sense? Yes, no? Somebody nod, really. I'm just like going to start playing some metal and we'll just headbang and then I'll think everyone is agreeing with me. Okay, so ZPool properties. Pools do have properties. It's not something you look at very often, but it doesn't have, in fact, have properties. And there are some very important properties to understand. Fail mode, auto replace, list snapshots. And we can see here what we're looking at is some of the properties associated with the pool here. You notice the first one, size, 1 tera, used, 634 gigs, available, 478 gigs, capacity, 57%. Okay? There's some things like here, like delegation. Delegation is one of the few topics I am not going to discuss today. I'm not going to discuss delegation. I am not going to discuss ACLs because they're stupid, complicated. They're really difficult to explain. I'm sorry. It's like lame. But fail mode describes how a ZPool should act when something goes wrong, when a device fails. And there are a couple of different ways you can set it. And if it's set as, say, wait, it will just wait for the condition to fix itself. You can also set it to continue, which means if it hits an error, it just keeps on going, which may mean it's going to run itself into a brick wall and bad things will happen. Or it can just panic. Panic is the one the developers don't like the best and sysadmins aren't so wild about. So list snapshots is a fun one because in the old days when you ran ZFS list to look at data sets, which we're going to look at a little bit more, it would show you all the data sets and their snapshots. And when it did that, it actually had to go out and get all the information associated with each of those objects, which meant if you had 1,000 objects, you type ZFS list, it could take like 60 seconds, which really freaks you out when you have like a production file server and you type ZFS list and it just does nothing. And your shell is locked up, right? You ever gone to like your big home directory or something like that and typed ls and it just sat there and your heart sank? Like, oh, that can't be good. It's fine, nothing's going wrong, but one of the ways to speed that up was to allow you to, by default, turn list snapshots off, and it doesn't show you snapshots by default, just data sets. We'll see a little bit more of that later. And then this other one here, it's very important. If you don't know about it, it will be kind of weird. Auto replace. Now you would expect that if you have a spare device and a device fails, that the hot spare should like hot spare. Hence the term. Except not necessarily. Because if auto replace is set to off, what do you think it's going to do? Nothing. It's going to detect a failure and it's not going to auto replace the device. So you're sitting there going like, you have a spare. Come on, you can do it. I know you can do it. Just replace the device. It's like, nah, you do it. Like, great. That's definitely one of those things that can put you in a, you know what, maybe I'm not so excited about ZFS anymore. Okay? So instead of hating ZFS, I just want you to know that it exists on your production machine. If you have spares, turn auto replace on. Which you can do. You notice we use a ZPool get all full name. You can set any of these parameters by ZPool set, say auto replace equal on, and the full name. Okay? Straightforward. ZPool history. This is a cool subcommand. Oh, it's awesome now because when something disappears for some reason, you can go look at the complete history of the pool. And this is awesome because it means when you have stupid administrators, you can find them, know what they did, when they did it, and fire them because they're stupid. Before you just went like, Fred, I know what you did. I don't know when you did it, I don't know how you did it, but you did it. I didn't do it, ZFS sucks, it's a bug. Like, no, I've got a log. You suck. Okay, so the ZPool history is very handy for finding kind of like odd things. And ZPool sizing. This is another one of those things I want you to know about because if you don't know about it, it may seem kind of confusing and you may get very angry at ZFS. So I just want you to know. ZFS reserves 1/64th of the pool capacity as a safeguard. Okay? Copy on write, like I said, when you write a block, it writes a new block. So if a file system becomes 100% full, you've got nowhere to write the new block to. You can't modify the file system. So 100% full copy and write file system is dead. Very dead. Right? So to protect against that, it reserves 1/64th of the total pool size to make sure that doesn't happen. Okay? So, then looking at the RAID types, a RAID Z1, RAID 5, offers you the raw capacity minus 1 drive. RAID Z2 is the capacity of the raw capacity of devices minus 2 drives. Same kind of math you've always used for RAID 5, RAID 6. Okay? So, and as an example, if I have a dynamic stripe of 4 100 gig devices, that's 400 gigabytes of capacity minus 1/64th. So we can actually just divide by 1.016, and we get the actual usable capacity of the pool at 390 gigabytes approximate. Always round your numbers when you do this math because, you know, it's approximate. So if we do the same thing for RAID Z1, 4 100 gig drives, subtract one of those as a parity drive, we end up with 300 gigabytes. Subtract a 64th, and you end up getting 295 gigabytes, and so on and so forth. Now you notice those are fairly straightforward, but when you get down here to RAID Z2 of 10 100 gig drives, offers you 800 gigabytes of capacity because you remove 2 drives to store parity, right? Minus a 64th, and you end up with 780 gigabytes. Now that can ruin your day. If you go out and spec a pool, a usable capacity for your new kick-ass ZFS machine, you set it up, and once you get this pool online, you realize, oops, I'm like 200 gigs short of the usable capacity I'm supposed to have. Going back and explaining to your manager how you got it wrong is not something I ever want you to have to do because he's stupid, you're awesome. So don't let yourself be put in that position. So just be aware of this math, okay, when you spec it out so that you can do these on paper and have an idea of what you're in for. Does this make sense? Please, I love silly questions.
So the 780 gigabytes actual viable in UTF, that's actual, when you do format usually you lose certain things.
Oh, this is on top of that. This is on top of that. Because of the fact that we actually do things in base 2 and drive manufacturers don't. Right? So yeah, when you buy a 1 terabyte drive and it's actually only 950 gigs usable, this is on top of that. This assumes the full capacity of the drive, usable capacity of the drive. Right? So if you've been in storage for a long time, this probably isn't something new to you, but this is the math, so this math will work out. Like I said, round your numbers, just for some fudge factor. But know this when you go and buy and size the solution. Okay? That's their way of saying you can use the mic. They're subtle. Go ahead, sir.
If the RAID is made of different sized drives, what's happening there? Or it can be?
Then you would just need to adjust the math.
Yeah.
In your sizing, you would just have to adjust the math. It would just get kind of funky, and you'd need like legal size sheets of paper to write it out. This is just a general mock-up, and like I use 100 gig drives just to make it easy on myself. But yeah, so just remember to, based on the RAID types, figure out how those are going to fit together, and then take out the 1/64th once you get done with that.
So there's no way of saying, here's the parity drives, and they happen to be sized right for parity.
No, because in a RAID Z, everything needs to be equal.
Okay.
So you can't use mismatched drives in a RAID Z. So this is that's one of the reasons why I said you might do something strange like have a mirror of RAID Zs. Say you went out, and this happens to people in their home machines all the time. You go out and you buy 3 450 gig drives, and you create a RAID Z. Well, then you go out and you buy 3 1 terabyte drives. And you don't want to get rid of those old drives. You could create a new RAID Z and attach it and expand it. And then it's all usable together, right? But they would be different sizes. So, but you do need to, all the drives within a RAID Z or RAID Z2 need to be equal.
Okay, thanks.
Okay. Any questions about pools that you want to ask here? Like I said, if you have big questions, you can ask them via email. Are we clear on pools? So that's all the tough stuff we have about pools. So now we know how to build this platform on which we can do fun, virtual, logical sorts of things. Okay? So it is currently 2 o'clock, 2:04. Yes, sir.
I have a question on mirrors versus RAID Z. So suppose I've got 4 disks. Would it be better to RAID Z of 4 disks or a mirror of 2?
Good question. I didn't put anything in here about performance necessarily. I might get some of that later on. But here's what I want you to know. Mirrors are fast. Super duper, super frickin' fast. Massively fast. RAID Z, not so much. RAID Z2, it's like grandma driving to the store in a Ferrari. She's going to get there, but it's going to take a little while. Right? She's going to be safe, but she's going to get there, but it's going to take a while. Mirrors are extremely fast. So to give you an example, a lot of us went out and bought thumpers when they first came out, or got them from Sun. And so we have this beautiful box with 46 usable disks, right? Take out 2 drives for the root. We've got 46 beautiful disks, and we go, I know, RAID Z2. Wow, it's big, gigantic RAID Z2s, right? We thought this is fantastic. You get all this capacity and all this safety. And then you run a benchmark on it. You're like, you got to be kidding me. That's slow. Then you take that apart and you say, you know what? We'll just bite the bullet. Let me just create a whole series of mirrors. You benchmark that, and you just can't believe how fast data's flying past your head. It's insanely fast. Mirrors are always the way to go. Whenever you need a high-performance solution, always consider whether or not you can use mirrors. RAID Z1 is slower than mirrors, and RAID Z2 is much slower than mirrors. Again, it's because you're creating parity, right? You're having to calculate parity, which means you're consuming additional CPU, and you're having to write that out. So you're doing additional I/O when you write the data out. Of course, the other issue is that when you read, the beautiful thing about a mirror is you have all these places to read the data from, right? So you can read from 2 devices, whereas you can only write. You have to write to both of them in parallel, but you can read from 2 in parallel. So mirrors are super duper fast. So if you have the time when you buy a large solution that you're going to build on RAID Z, do your testing if you can. FileBench is a fantastic tool, but test it if you can. And I know mirroring isn't so sexy because it's so expensive, but if you can do it, do it. Okay? So we're going to take a quick break. Let's say 5 minutes. Go to the bathroom, get some water. Maybe there's coffee outside if we've been good. And then we'll get going again with the rest of this. Okay?